Hi, hello, good evening everyone. Welcome to India's largest e-learning platform, Gradeup, and welcome to the session Score Booster NIELIT 2020. Join the session quickly and mark your presence, everybody. Good evening, Pragun. Prudvi Krishna, good evening. Dhananjay Gupta, good evening. How are you all? Ajit Yadav, Learner 123, Reshma, good evening. Monica Rani, Nishita, Arnab, Ani, good evening all. Good evening everyone. So today we will discuss the concept of time complexities. Okay. So before I start, let me quickly introduce myself. I am Satya Narayana with all these credentials, and I teach computer organization and architecture, computer networks, operating systems, data structures, and algorithms. Everybody, hello, good evening, welcome to the session. So guys, before we go for problems, what is important for NIELIT exam with respect to time complexities is, firstly, whenever we say time complexity, everybody, here I am not discussing any topics, any concepts, but I will tell you what you have to look at with regard to time complexity. Firstly, asymptotic notations. Okay, means whatever the big O notation, big omega notation, and theta notation. Like we say, this is the worst case time complexity, this gives best case time complexity, and this gives average case time complexity, right? So how to represent the time complexities in best case, average case, and worst case with big O, big omega, and theta? Firstly, you have to look at, because that is the representation of time, execution time. Then once you are good at these asymptotic notations, then immediately go for searching algorithms and their time complexity. Like mainly we have only two searching algorithms. One is linear search, other is binary search. Like big O of n, big O of log n. Then once you are good at searching algorithms, once I recommend everybody to go through towers of Hanoi problem separately. Of course, sir, it is a part of recursion and all. Still, go through this towers of Hanoi problem, how to solve this with 3 disks, with 4 disks, and what are the minimum number of moves we do. Okay. Then Anil, are you also taking computer network subject? Yeah. From tomorrow we will discuss questions from computer network subject. Anil. Okay? Yeah. Then guys, sorting algorithms. Sorting algorithms. What are different sorting algorithms? Means there are many sorting algorithms, guys. Basically, I tell you to go through at least 6 different sorting algorithms. They are selection sort, insertion sort, bubble sort, merge sort, quick sort, and heap sort. Okay? So these algorithms time complexity at least you go through in all the cases. In best case, average case, worst case, please go through the time complexities. Any case may be asked as question. And with respect to sorting algorithms, again, there are two different classifications for sorting algorithms as stable sorting algorithm, unstable sorting algorithm. Stable sorting algorithm means whenever duplicate elements occur, while sorting, those positions should not be altered. Means positions means it's not exactly the same position. If one eye occur before another eye, their relative position should be always same. Then we say it is a stable sorting algorithm. What are different stable sorting algorithms? You just remember this easy convention, IBM, are stable. Insertion sort, bubble sort, merge sort. These three are stable. And the other are unstable, like quick sort, selection sort, and heap sort. They are unstable. Similarly, there is another classification for sorting algorithms, that is external sorting, internal sorting. If extra memory is not needed while sorting, that is internal. Other than allocated array, if extra memory is needed, then we say external sorting. So we have merge sort as external sorting algorithm, while other sorting algorithms are internal sorting algorithms. So sorting algorithms time complexity is very, very, very important. Okay, go through them. And then for what else you should spend some time with relate to time complexity means we have algorithm design techniques, like dynamic programming, greedy method, with relate to NIELIT, divide and conquer, branch and bound. Backtracking is not in NIELIT syllabus, so leaving that. Now I will write some important algorithms. Please make a note of those time complexities after you revise. I don't tell now because it's not spoon feeding. I will only tell what is important now. So when you search for it, when you frame a note on it, you will remember. Okay. So what to note? First of all, matrix chain multiplication. It belongs to which technique and what is the time complexity? Okay. Then Strasson's matrix multiplication. This is what technique? What is the time complexity? Then SJ, binary search is sufficient, or we have to go through all other searching algorithms? Means what other searching algorithms you are referring for? Chronological searching, or what you mean to say? Okay. Then all the data structures like queue, linked list, stack, time complexities for insertion, for removal, those time complexities you go through once. Similarly, trees. Then the time complexity for breadth first search, depth first search, Prim's algorithm, Kruskal's algorithm. Okay. Hashing is, however, there is a part SJ. Hashing is already part, and other algorithms not required in algorithm subject. Maybe they may be required for you in compiler design. I am not sure, but in algorithm subject they are not needed except hashing. Then you definitely have to go through the time complexities for traveling salesman problem, distro algorithm, Bellman-Ford algorithm, upper bound, lower bound, upper bound what worst case, lower bound best case, and Floyd-Warshall algorithm. And of course, I told you to go through towers of Hanoi specifically. However, what is the time complexity for that? Okay. And then this one, knapsack problem. 0, 1 knapsack. Okay, let me write just knapsack so that you can understand both the 0, 1 and fractional knapsack. Both are important. Okay. Krishna Vidya Vaidya, you should know asymptotic notations. Krishna Vaidya. Asymptotic notations you should know. So that you will understand how to represent the time complexity. What is the meaning of input size and all. Alright. So guys, you try answering these questions now. Which of the following sorting algorithm is slowest under average case? Under average case, which is slowest means which takes more time. Come on, give your answers everybody. Pregun is telling insertion sort. Arnab Karan, insertion sort. What about others? I want response from everybody. Dhananjay, Mokshada, Riman, Nishita, alright. Mehnaz Siddiqui. Okay. So definitely this is insertion sort, guys. So what is the time complexity? Heap sort time complexity is big O of n log n. Merge sort big O of n log n. Quick sort big O of n log n. But insertion sort is big O of n square. Hence, insertion sort time complexity is more. Okay? Alright. Go through this problem once and tell me what is the answer. Consider three algorithms A1, A2 and A3 to solve a problem P. A1 takes big O of log n, A2 takes big O of 2 power n, A3 takes big O of n cube. So which is slowest? That means which take more time. Obviously exponential time complexity. In these three, we can say log n is smaller than n cube than 2 power n. Definitely. So, algorithm A2 is slowest because it takes more time. Right? Next question. Selection sort and heap sort are unstable sorting algorithms. True or false? Selection sort and heap sort are unstable sorting algorithms. Everybody, what do you feel? I already told you one simple techniques for remembering stable. What are stable sorting algorithms? IBM. Insertion sort, bubble sort, merge sort. These are stable sorting algorithms. And selection sort, heap sort, quick sort. These are unstable sorting algorithms like IBM SHQ. Okay? So, selection and heap sort are unstable, true and true. Good. Next question. The time complexity of quicksort algorithm under worst case is worst case time complexity. What is that? Big O of n square. It is not just the time complexity, but you should also see worst case time complexity. Okay? Next. Guys, currently at Gradeup, 3 different courses you can see: Gear Up, Rank Up, and Vision 2022. If you are in the second year or third year aiming for 2022 GATE exam, then Vision 2022 course is for you. If you already know some concepts and looking for more and more practice questions, then Rank Up is for you. And you want to make your concepts strong, then Gear Up is for you. So, for all kind of students, Gradeup is bringing the courses, and very soon MSQ specific courses we are going to MSQ specific course is going to start. So like this guys, we will be coming with innovative useful courses time to time. So how to access all these courses? By only one way, that is by subscribing to Gradeup Super. So not only for GATE, even for ISRO, BARC, NIELIT, DRDO and other PSU exams also we do courses. All the courses you can access with only one subscription. So, why late? Subscribe to Gradeup Super guys. And we are the faculty who are having Mr. Murali Krishna Sir, who is having 20 plus years of experience, and it's me with 13 plus years of experience, Mr. Ankit with 8 plus years, Mr. Navneet with 7 plus years. We are all teaching for GATE students and other PSU aspirants since many years. So definitely we can guide you, put you in proper track guys. Okay? GATE 1 mark level and NIELIT level we can relate as same. Mahnaz Siddiqui. Okay? Right. Next question. Which of the below sorting algorithms will change the relative order of position of non-distinct elements in the list? Which will change the relative order of position of non-distinct elements in the list? Tell me. Just now we have told. What does this mean? If it will change the relative order, that is called unstable sorting algorithm. Which is unstable? IBM is stable. So obviously selection sort will be unstable. So in this way also, without using the term stable or unstable, you may get a question from sorting algorithms. Okay? Next question. The average case time complexity of merge sort algorithm is, we want merge sort average case. What is that? In best case, in average case, in worst case, in everywhere, merge sort algorithm time complexity is the same. That is big O of n log n. As it is average case, I am writing it as theta. But every average case time complexity you can represent as big O, no problem. But not vice versa. So theta can be represented as big O, but not big O as theta. No problem. Okay. Next. The time complexity of Fibonacci series using recursion method is. So guys, just recall all the time complexities with this session. That is what the motto behind it. And please don't forget to like the session, share it to all your friends, and subscribe to our Gradeup Gate channel. Quickly do that, guys. Just like the session quickly and share it to all and subscribe to our Gradeup channel, please. So, under recursion, it is exponential time complexity. Just like if we want Fibo of 5, let's say, you will be calling Fibo of 4 and Fibo of 3. Fibo of 4 again call 3 and 2. 3 again will call 2 and 1. 3 again call 2 and 1. 2 again call 1 and 0. So 2 call 1 and 0. So 2 call 1 and 0. So like this, if you look for a big n value, it would be almost like a perfect binary tree, and it would be almost 2 power n recursive calls will be made. So that would be big O of 2 power n. Recursion method, Shiva, recursion method. So 2 power n. Shiva, maybe you are thinking binomial heap or Fibonacci heap. It is a simple Fibonacci series. Shiva. Okay. Next. Fibonacci series using dynamic programming is. Using dynamic programming. If the same Fibonacci series you implement using dynamic programming, now what is the time complexity? What dynamic programming says? Bottom up approach. Take an array, save Fibo of 0, Fibo of 1, Fibo of 2 is equal to 0 plus 1. 1. Fibo of 3 is equal to 1 plus 1. That is 2. Fibo of 3 is equal to 1 plus 2. That is 3. Fibo of 4 is equal to 2 plus 3. That is 5. So instead of recursive call, we are just retrieving the values from array. So it's a constant time complexity. So before recursive call is made, we are verifying whether the result is available in the array or not. If it is available, simply we are retrieving it. So it is big O of n, just n. That is what the dynamic programming advantage or greatness, no? Bringing exponential time complexity to linear time complexity. Here space complexity is more because we require another array here. But time complexity is less. So no repetitive work here. Same work we will not perform again and again. No overlapping of subproblems. I mean to say, no rework, no overlapping in the sense subproblem we will solve only one time, its result is preserved. Right? Next. The towers of Hanoi problem with n disks can be solved using. This is very, very, very important, guys. Towers of Hanoi problem with n disks can be solved using 2 power n minus 1. 2 raised to n minus 1. So we have a tower where we have A, B, C. So we have tower 1, tower 2, tower 3. So we have to move from tower 1 to tower 3 using tower 2 so that always on big only small should be placed, on small big should not be placed. So 3 disks are there. So here it requires 7 steps. You can see we will move C. This is the first step. Or let me do this. Move C to tower 3 directly. Okay. Then move B. So B here, C here. Now move this C here. So 1, 2, 3. Now here A is not there, B is not there. Sorry, B is not there, C is not there. Now bring A. So let me write C from tower 1 to tower 3. Then B from tower 1 to tower 2. Then C from tower 3 to tower 2. Then A from tower 1 to tower 3. Then C from tower 2 to tower 1. Then B from tower 2 to tower 3. Finally C from tower 1 to tower 3. So total how many steps? You just try these operations so that you will understand. So 7 steps. Very, very important question, guys. This is. So Channakeshwali is telling, sir, this question is asked in EESL exam. Yeah, it is very, very popular bit for competitive exams. Okay. Last question of the day. The recurrence relation for merge sort algorithm is. So for sorting algorithms, you are going through means not only time complexities, but also go through these recurrence relations. Okay. So quickly tell me what is the what is the recurrence relation of merge sort algorithm? Merge sort, we will divide the list into 2. For again we will divide it into 2. So first we will divide it into individual elements, then while merging, while conquering, we will put them again in the order. So 2t of n by 2 plus big O of n. Sir, why it is not best case or average case or worst case? In every case it is same. In every case it is same. So option C. Namrata, Dhananjay, Sanket. Option C. Quicksort has a different recurrence relation for average case and best case. So to tell you that you go through these recurrence relations, that is also important. Question may come in this way. I have kept it this question, guys. Okay. So I believe you understood what to prepare with respect to time complexities. That's why I have titled it as spend some time for time complexities. So how you should spend that time and what you are supposed to learn. That is what I have presented. I believe you understood what to prepare. And these are our Gradeup Gate 2020 achievers, guys. 60 plus candidates achieved ranks below AIR 100 by taking our courses, and our test series or our study notes helped them in getting AIR below 100. Arnab Karan, yes. So what Gradeup Super will give you? It is a single subscription which gives unlimited access to all structured live courses taught by India's best faculty, and complete doubts will be resolved, full syllabus coverage, all mock tests are prepared by toppers only, and we do follow latest exam pattern. So why late? Subscribe and recommend our Gradeup Super, and if you have any issues, you may call us on this number, guys. Alright. So if you want information about my classes, when I will take what, complete information, and if you want to ask me anything, do one thing. First follow me on Gradeup app, and then you can tag your doubt at Satya Sir. That will be directly coming to me. Alright. Dhananjay, I am not aware of that. Siddiqui, what time complexity video you mean to say? On our Gradeup app, free class is there. I taught on our Gradeup app, but not on YouTube. My class will be there, I think, on Gradeup app. So this is the super subscription fee: 6 months 12,000, 12 months 16,800, 24 months 24,000. So for more period you take, you will be paying less per month basis. It is very, very beneficiary, guys, for students. So this is our email ID and phone number. For any issues or concerns, you may reach us. Okay, in GATE 2020 Score Booster series, I think I taught. Oh, thank you, Pragan. Please share that to them. Okay, fine, guys. That's all for today. Tomorrow we will practice IP addressing, which is a computer networks topic. So don't miss tomorrow's class, which is very, very, very important, which is very interesting. Okay. Sure, Pragan. Definitely I'll answer. That's what, Mohan. You can call us so that the subscription details they will tell. I am not much aware of it. Mohan. Thank you. So subscribe to Gradeup Super, get unlimited access to all structured live courses and mock tests. Thank you so much, guys, for joining. Join tomorrow without fail. Good night, everybody. Prep smart, score better, go Gradeup. Thank you.